Okay, good morning, everyone. Good morning. How are you all today? Are you bracing for impact? So we're very excited to have you all here, and welcome also to all of you who are accessing us via the webcast. So there's going to be a simulcast, and we'll be getting questions from all of you out there, and hopefully the conversation can all come together in here. So thank you very much. We're very excited this day has come. Bracing for Impact, the Artificial Intelligence Challenge. I'm Professor Giuseppina D'Agostino, and I'm the founder and director of IP Osgoode. That's Osgoode's flagship IP and tech program, and I'm one of the organizers for today, along with the driving forces, and I see Ian Stedman and Aviv Gaon, who've worked tirelessly with me on this. So if you haven't already done so, I do encourage you to go online and check out ibosgoode.ca. There you'll find all that is new and exciting in IP here in Canada and around the world. We do have Wi-Fi access, LSUC public. So make sure you go online and also tweet away, hashtag IPOsAI Challenge. Now, I should mention the conversation always continues. We have a group of IPA editors that are going to be blogging on today, and we'll be uploading that blog along with the recording all on the website. And I should note also that we'll be having your pictures taken today, so there's going to be a photographer going around. Now, one of the many hats I wear, I'm the editor-in-chief of the Intellectual Property Journal, and we'll also be working together with Aviv and Ian in convening together a special issue of the Intellectual Property Journal. Now, many of you might know IP Osgoode really aims to inject many more voices to the IP debate and intensify the learning opportunities for our students here in Canada and around the world, and build closer bridges from within academia and also with industry, with government and other expert groups. And as many of you might know, IP Osgoode, I guess I started in 2008, and it's 2018, so it's our 10th year anniversary. And in the last 10 years, we have canvassed the whole panoply of hot topics in the IP and tech community. But really, I can think of no better topic as we kick off the next decade than to begin discussing AI and really leading the conversation here. And it's really a unique moment in time where academics talk about issues, but we're actually in the same room talking with government, because government has this at the fore of its agenda. There's the PanCan strategy, which is across Canada. Here in Ontario, we're deploying many resources to AI. So the timing is now, and there is a sense of urgency that we need to get a roadmap going. And so today is the beginning of that. And I'm excited to say that we've been able to bring together a really vibrant group of expert speakers, moderators, and of course all of you in the room to have that conversation. Now, I would like to thank all of you, along with all of you, really the speakers. They've come from all over the world. So really, it is an international conference. So from within Canada, we have representation from the US, the EU, Australia, and Israel. So I would like to thank all the speakers and moderators for your natural intelligence. Now, I'm very proud to say that we also have some staunch collaborators, and I'm grateful to Dov Greenbaum from Zivi Meitar, IDC Herzliya, so it's in Israel, and also the York University Center for Public Policy and Law. And of course, our supporters, we have the Canadian Institute for Advanced Research, who are also leaders in this area. And York, of course, the VPRI, the Vice President's Office of Research and Innovation, has been supportive. Osgoode, of course, our Research Intensification Fund, the Lausanne School of Engineering, and SSHRC for a very timely and appreciated Connections grant that we got for this conference. A special thanks, of course, goes to the entire organizational team, and no event of this size is ever possible without many people behind the scenes working. And Michelle Lee is right there, and she's been leading the charge there. So thank you, Michelle. And Mary Barbieri, there's Joe Turcott. I think he's still minding the table. Oh, there you are, Joe. Excellent. And of course, Will Foster, who's actually, there you are. So he was my student last term, and you're my student again this term. So thank you so much, Will, and everyone else for helping out. Now, at this time, before we get started on our panels, I really want to take this opportunity to call up here the driving forces behind this conference, so Ian Stedman and Aviv Gaon. So Ian will be, okay, so the dynamic duo has a represent. Aviv's not coming.
Camera shy.
Okay, so.
Thank you.
Yes, and thank you.
So thank you, Pina. I just wanted to take a minute to thank you all for coming. This has been a year's worth of planning, and we're really thrilled to see it all come together. Aviv and I are both PhD candidates at Osgoode Hall, and I'm sure a lot of you here have some connection with Osgoode, have a graduate degree, or have been there for your law degree. If you haven't, you really should consider. Osgoode has these centers like IP Osgoode and the York Center for Public Policy and Law that have really afforded us an opportunity to kind of do our thing as grad students and do something like this. So if you're interested in a law degree or your grad degree, I would highly recommend Osgoode. I was going to thank Michelle too, so you've stolen my thunder on that part. But I just want to quickly say thank you. We really appreciate everyone being here and taking the time out.
Thank you.
On to it.
So Ian, of course, is Osgoode's Dean Sawson's PhD student, and Aviv is my PhD student. So that's also another nice connection. So what we'll do straight away is convene the first panel. So if I could have the speakers come up, and we'll dig right into it. Okay, so two of our speakers will be joining us virtually. So there'll be two of us up here. So thank you very much. So this panel is really meant to set the tone for the day. It's sort of to set up the big issues. And really, we're looking at the issues in the medical, the health space, talking a bit about Uber too, and the overarching issues of data and privacy. And all of these issues really seem out there, but they affect our lives in very intimate ways. And so I think I'm really in humbling company here, especially here at this table. And those of you, our two speakers that will become, are you there actually?
I'm certainly here.
Oh, perfect. Okay, awesome. Okay, you're waiting for my cue. Okay, so what I'll do is I'll introduce our speakers by speaking order, and they'll have about 15, 20 minutes to speak, and then we'll have some time for a Q&A. And also, those of you on the webcast, make sure you write down your questions and send them our way, because we'll be looking at those and bringing you into the conversation, okay? So I have here to my left, I'm so happy to finally have Ian Kerr. Of course, he's a legend in this area. So he is a professor at the University of Ottawa, and he also holds the chair in ethics, law, and technology. And then to his left, of course, we have world-renowned doctor. His name is Ronald Kahn, and he is the chief pediatrician at the world-renowned Sick Kids, which is just down the street from us. Accessing us through by voice. Hello, Ryan. We have
Hello there.
We have Ryan Callow, so he's a professor at the University of Washington School of Law, and Deirdre Mulligan. She's a professor at Berkeley, and she's the faculty director of the Berkeley Center for Law and Technology. Hi, Deirdre. Not
hello,
here.
nice
Oh, hello. Okay, good. Okay, so excellent. So Ian, why don't you kick things off for us and make sure you're all taking down some questions. Okay.
Great. Well, good morning, everybody. It is wonderful to be here at Osgoode Hall. I have long-standing memories about writing my bar ads here many years ago. Shiver, shiver, shiver.
Yeah.
And it's also great to be involved in an event with Osgoode Hall, the law school. And I thank IP Osgoode and Pina, and in particular Aviv and Ian for the invitation, and commend you on this incredible undertaking you've done, which is a fabulous set of role models for I think, graduate students and PhD students to say, hey, you know what? You're not doing this here. We're doing this here. Let's bring this, this conversation and get it rolling. It's also great to be in the same room with my colleague and friend, Karis Craig, who I think of as the preeminent copyright scholar in Canada, also an Osgoode Hall professor, as well as Beda Amani is in the room. And I just want to quickly acknowledge my cousin is in the room, Ron Perlman, who people outside of the law, and some inside of the law, of course, would know is a pillar, a virtual and actual pillar of York University as a scientist for many years. And I'm just feel so lucky that I have you here and we get to interact in this way as well. So this is a panel, I guess, about industry and AI. And I'm going to focus my remarks on a chunk of what my research is about these days, which is trying to address and unpack some of the questions that arise when AIs start to outperform human beings. The particular example of focus for me will be when machine learning involves itself in medical diagnostics. And as we had a nice discussion about yesterday, it's getting pretty interesting out there. So this, as many people will know, is Geoffrey Hinton, sometimes dubbed the godfather of machine learning, and a Torontonian, these days half with Google and half with the Vector Institute, formerly a professor of computer science at the University of Toronto. And really, I think, one of the key people who's made this a reality, this pressing reality, this idea that we have to brace for impact. He is the developer of backpropagation, which is one of the key techniques in machine learning. And in his own comments about what happens when AIs outperform humans, especially in the context of radiology, which is going to be the example I talk about, here's what he says. He said, I think that if you work as a radiologist, you are like Wile E. Coyote in the cartoon. You're already over the edge of the cliff, but you haven't looked down. There's no ground underneath. It's just completely obvious that in 5 years, deep learning is going to do better than radiologists. It might be 10 years. That's his quote. So, in thinking about this idea of bracing for impact, and I take it the metaphor is apt, I wanted to sort of challenge that a little bit. And are we really bracing for impact in that kind of way? And I'll start with offering a bet out to anybody in the audience. I'm willing to bet right now a large pizza that 10 years from now, radiology will continue as an admirable profession. It will continue to flourish. And although it will change like everything else in medicine, radiologists aren't going over the cliff like Wile E. Coyote. Anybody want to take me on that bet? 10-year bet? I see no hands. Okay, so I think we have to take a bit with a grain of salt this idea of bracing for impact, at least in the Wile E. Coyote sense of that. It's not maybe necessarily going to be about that, except when it is. This is the most recent Tesla car crash, which once again is probably the result of overtrust by humans in a marketing slogan by calling that Tesla Model S autopilot when it has nothing like level 4 or 5 autonomy. And in some senses, we will have to brace for impact, because if we delegate AIs certain kinds of things like the driving function in vehicles, we're going to have to expect that we're going to have some bumps in the road. I think we'll also be bracing for impact as we look more and more at the question of weaponizing AI, as we're starting to see large discussions about this for the last 3 years at the UN, which I've been involved in. But I want to suggest to you that it's not really, in general, going to be about bracing for impact. And although my mom taught me when you get invited out for dinner, you shouldn't critique the menu, I thought I should start at least with that concept. And here's why I think that, right? AI has actually been around for a long time. The term was coined in 1956 by John McCarthy at a special conference that was convened on the early versions of neural networks in 1956. And what we've seen, if you look at that slide there, is that there have been periods of AI that have had huge productivity and success, usually followed by what one might describe as a winter, where the winter is not much progress in the field, but also, as a corollary, not much funding in the field. But we are now somewhere in a really interesting state, and that is machine learning since at least 2001 has made significant advances of the sort that I think people have been waiting out to see. And so we live in interesting times, right? But this is the view from here. We're on what looks potentially like it's an exponential curve. And it's hard to know what's next, right? That's the nature of the human condition. The singularitarians, as we learned yesterday at the round table, have this view that it's going to be a sharp exponential curve. It's like good Canadians, we are at the sort of tail end of the hockey stick, and things are looking up from here. But I would suggest to you, and the singularitarians would go even further, and they would say, you know, in fact, we're so used to rating our progress in a linear scale that we're actually underestimating what the technology will do. We'd have to correct that curve for the fact that this is an exponential curve of progress. But I would suggest to you that an equally plausible future for us looks like this. Right? We're in an exponential phase right now, but then maybe there'll be a stationary phase, and then possibly even a death phase. This is the growth curve for a bacterium. But we stand here, and as Steve Jobs, I think, so eloquently said it several years ago at a Stanford commencement, we can only connect the dots looking backward. We can't connect the dots in the forward direction. And so, to some extent, we'll have to wait and see. But I do think, and one of my main remarks this morning is going to be, we should sort of temper, to some extent, the way that those metaphors sometimes get out of control in terms of their hype. And we should really think about what's going on in the present. And so, with that in mind, I want to talk a little bit for a few minutes about AI, and then talk about this work that we've been doing about when AI outperforms humans in the medical context. So when we think of artificial intelligence, we can think about it in a number of ways. And many people have gone to great lengths to distinguish between different kinds of AI. Those funny words up there, the first one is that we can think of AI in a narrow sense, and think of AI narrow intelligence, artificial narrow intelligence. And when we think of AI in that way, the idea is that the AI is really, really good at one thing, or a very narrow range of things. Maybe better than the best human experts in those things, but it's only for a narrow range of things. Some people have thought that where we're going to lead to next is AGI, artificial general intelligence. That's when an AI has the kind of general intelligence of an intelligent being, perhaps a human being. That's a little bit far out and speculative. It's an interesting thing to think about, and maybe it's a thing we should be planning for to some extent. But I think the important thing for people who are new to this field is there's a lot of writing out there that would have you believe that we're in a state of artificial general intelligence, and we're not. Some people are interested in stretching that concept even further and talking about artificial superintelligence. I like to leave that topic to the speculative philosophers. It is of great value for thought experiments, but not great value for thinking about today's policy, I would suggest. So my approach is going to be to say we should focus on narrow artificial intelligence. We should not focus too much on AGI or superintelligence in any kind of way. And so that's what I'm planning to do. So the main concept that I think of when I think of AI, and we talked about this a little bit yesterday for those who participated at the roundtable, is this concept of delegation. Interesting questions will start to arise when we see that AIs are better than human experts, maybe better than young lawyers, at doing certain kinds of legal work. And the question is, to what extent and at what point do we delegate the kinds of tasks that were exclusively done by humans before and now let the AIs do them, right? When do we let go of the scalpel? When do we take our hands off the steering wheel? When do we let the robots fire the weapons? When do we let the robots make medical diagnosis? These are the kinds of questions that I look at regularly and try to dig deep and find answers to. So I want to talk a little bit about the technology for a couple of minutes and then just talk about some of the work in the legal context. No, this is not the cover of the Abbey Road album, although it kind of looks like it. This is actually an object recognition technology that uses machine learning to try to recognize objects. If we ever get to a state where we're actually using level 5 autonomy driverless cars, where the humans, maybe there's not even a steering wheel in it, these devices are going to have to get pretty good at object recognition. And the point is, and this is what makes the AI story so interesting, is that up until now, the way we would achieve these tasks is by having programmers think really hard in advance of what the objects are on the road. And that's not going to be plausible. So the thought is now, no, we teach the machines to learn about what objects there are, and through machine learning, they'll actually get good enough that they can handle every situation that the programmer, for example, might not have thought about. And so when we think about machine learning, I think the thing that's important to understand here is that AIs can be trained in particular ways, but the important thing is to see that they can be trained to go beyond their own programming. That's what's so interesting, at least from a legal and ethical perspective, is that the AI is now doing things that it was not told to do, and perhaps that it was not expected to do, right? And that's the point of having software that learns. So one of the fields that this has been very, very effective in is medical diagnostics, and that's going to be sort of the focus of what I talk about. And I won't get into the technicalities about how machine systems are trained to do these kinds of tasks, but machines have become very good at spotting tumors, for example, a job up until now held by radiologists, and a job that at least Jeff Hinton thinks won't be for radiologists to do for much longer. And so back in 2012, we started seeing headlines like this. And it was interesting for me to look at the author byline there. I realized it was a different spelling many years later. But in any event, we are starting to see progress such that systems like IBM Watson are diagnosing cancer well. And in some cases better than doctors. And I thought the headline from last year was kind of even more interesting, which is that these systems in some cases have given diagnoses for patients in situations where the doctors got it wrong and where the doctors were stumbling. That's a very, very interesting prospect to think about. And the way that this happens, it's very important to put this on the table for those who are sort of just coming new to this topic, is that these machine learning systems are extremely effective at pattern matching. They can see patterns in the data that people just can't see. But as such, what they are good at in spotting patterns is they're good at correlation. They do not speak to causation. They do not speak to theory. They do not speak to any of the things that medical science has been founded upon. And that's kind of an interesting dilemma, because you get a situation where a pattern matching machine outperforms a doctor, but on a whole different methodology, and on one which the doctor won't really be able to ever understand. I mean, maybe after the fact it can be reconstructed, but not necessarily in the usual human terms, and certainly not in causal terms. And we saw some interesting examples of that. A couple summers ago, the grandmaster of the ancient Chinese board game Go, Li Sedol, was defeated by AlphaGo, which was a DeepMind's, i.e. Google, project. And what was so interesting about that compared to when the machines beat chess was chess is a linear mathematical game you kind of expect that computers can do well at. But Go is a very intuitive game. And it was interesting to watch what happened there. There's this famous move in game 2 of the match, move 37 in game 2, where AlphaGo performed this move and none of its human programmers had any sense that it would ever do that or why. The commentator of the match described it by repeating 3 times that it was magical. It was magical. It was a beautiful move. No human would have ever done that move. And what we're starting to see here is a kind of emergence that is taking place. In other words, this kind of behavioral outcome that was not expected or anticipated. That can sometimes lead to forms of intelligence, but it can also lead to unintended consequences. And so that's one of the things that the law will have to grapple with, at least in terms of liability. These systems, or at least some of them, are unpredictable by design. The fact that we don't know what they're going to do is a feature, not a bug. That's really important to recognize. We saw this when IBM's Watson played Jeopardy, and it had this famous clue about what US city ... and it guessed what is Toronto. And they went to try to reconstruct why would the machine have done that and made that kind of an outcome. So I'm interested in these kind of things when we get to the point where the machine systems are at least as good, if not better than human beings at diagnosis, but there's a situation or a case of human-robot disagreement. The doctor thinks one thing, the machine system thinks another thing in terms of what the right diagnosis is. Let's imagine, as is the case, that the machine system has a better overall track record. And what are we to do in these kinds of cases? Luckily, at least in some reports recently, there's a great overlap in the outcomes between machines and doctors. These reports speak of 99% agreement. But it is interesting to think about the 1%. Right? And it's particularly interesting to think about this idea of what do you do in those 1% cases where the machine learning system has a 90% batting average and the doctor only has a 50% batting average. And to me, this evokes this image of the angst of Abraham on the mountain, right? The primary physician in that case is thinking about what to do. Here's the authoritative voice, and the voice of God telling him to sacrifice his own son, in this case, the machine learning system saying what the diagnosis is, and having to decide between the doctor's own intuitions versus what the machine tells them ultimately. And these kinds of situations are what I think is so interesting when there's an outperformance of the doctors. So I don't think it's going to be exactly like the Wile E. Coyote. I think it's going to be a real problem we're going to solve. This is a screenshot of the table of contents of a paper that my colleague Michael Frumkin and Joël Pineau have released today, timed it with this conference. It's on SSRN now. And it asks the question about what we do about these things in the case of medical diagnostics. And in thinking about this, part of what we're interested in, I'm just going to give you a quick snapshot to stay on time, is we're very interested in the unintended consequences of tort law. Our argument, and we spell it out in quite a bit of detail and analysis, is that current malpractice law will actually require that hospitals rely on the AI rather than the doctor in these cases of disagreement, once the AI is demonstrably better or outperforms the human being. And that might seem like a relatively natural outcome if you think a little bit about standards of care. But when you start to think about what that means for hospitals, for insurers, for doctors, for the profession, for tort law, for economics, it becomes actually a very, very interesting proposition. And in our paper, and I just give you a quick snapshot of this, what we try to demonstrate is that current focus of the law, medical malpractice law through tort, will ultimately generate a dangerous over-reliance in AI. And basically what we're getting at here is that we can imagine a situation where after the AIs are starting to be relied upon, and after a generation of new medical data comes into play where it's all AI-based decision-making, it's pretty hard for the humans to get back in the game and to really understand in any meaningful way what is going on, to the point that we will cede those decision-making to the machine systems that work, but without really having a causal story to tell and without really being anywhere in the room when it comes to what we think of as medical science. In some cases, this will demand a reduction. This will reduce the number of demand, the amount of demand for specialists. I think in the same way that if we talked about this in a law context, the organization that owns this building isn't going to let lawyers go away anytime fast. I think the doctors are pretty good at hanging on to that too. But I think it will change the nature of things in an important way. It will certainly lead to certain kinds of medical de-skilling. We're seeing that in surgery already. And that may not be a bad thing in all cases, because if the machine systems are reliable and we can continue to use them, we don't need to have those skills anymore. But I think it leads to something that no one else has talked about before this paper that we wrote, which is that the combination between AI and tort law and economics could potentially drive humans out of the knowledge loop in the way that I've tried to describe very briefly. Obviously, I can't do the full paper in the time that's allotted. But the way that I'll describe it is this, as I come closer to wrapping up here. It will lead to what I call an Asimovian paradox, the kind that you would see in an Isaac Asimov story, right? Here's how I say it. The normative pull that leads to a decision to delegate to the AI, namely evidence-based reasoning, right? So as soon as we have evidence that the machine system outperforms the human, the normative pull will generate a system in which we now have no obvious evidentiary rationale for explaining the outcome that's generated by the machine. All we have is a hindsight case. And that's a problem. It's a problem for liability schemes, but it's also a problem for the future of medical knowledge. And so in our proposal, we look at a bunch of different possible solutions to this problem. And I'll save you the long story and cut to the chase. Where we get to in all of this is we suggest that the definition for the standard of care, whether it's put forth by judges or whether it's legislated, is that we're going to need to legislate, or we're going to need to enact as law in some way, shape, or form, the idea that we keep the human in the loop. That it's that slide should say human plus ML, the human plus the machine learning system. And that's a pairing that's not only good, because we've actually started to see that the hybrid of human and machines can produce outcomes that are better than the best human could or the best machine could. The Centaur chess games that have recently been going on. We think that that's what we're going to have to do. We're going to have to basically legislate that the human remains in the loop. And in doing that, we have to recognize and we have to get past what we might call the neoliberal fantasy, right? This is the idea, and you hear it a lot in government talk about AI coming in and bringing the costs down and being able to really, change the economics. I think, in fact, that what we're trying to suggest is it's going to get more expensive, because now we're going to have the AIs and the medical doctors. And that's not a bad thing if you value healthcare, because we're going to have amazing outcomes and things that we never had before in the same way that we do with, for example, functional magnetic resonance imaging. Incredible technologies, but expensive technologies. So I'm sort of here to sort of bust the bubble to say that AI is going to not only save the world, but it's going to be dirt cheap. We conclude that that's not going to be the case, but it will be expensive. And so I think I'm going to leave it there. I'm going to thank you very much, and I can't wait to hear from my colleague Ron, and also my dear friends Ryan and Deirdre, who are on the other end of this cyber setup we have here. Thank you very much.
Good morning. Thank you for having me. I don't have slides. Let me start with a disclosure. I'm not a medical bioinformatician. I'm not a computer scientist, and I'm for sure not a lawyer either. So you're going to ask yourself, why am I here? And I will admit to you that when Ian emailed me, I was asking myself too, do you really want me to be here? So he said, now talk about AI and healthcare. So what I'm going to do now, a couple of things. I'm going to give you a few of my own thoughts of where I see AI play a significant role in healthcare, with the question, the mandate to you that a number of these things will need regulation. And I ask you as the lawyers to think about this as with the question in mind, how can we make it happen? How can we enable it, rather than how can we prevent it? I think that's the critical piece of this. The good things, if you don't have slides, is you can speak to the points your speaker made before you. So, number one, I'm glad that you want to legislate the human and the AI as together. Because it's interesting, when you talk to healthcare providers, or physicians specifically, some of them, and it's not just the old guard, are actually scared about AI because they feel like, am I going to be replaced? And I would agree with Ian. I don't think there's a replacement issue as much as there is a different scope of what you do. I actually think it's not just the AI that's going to be expensive. There will be different people who will be part of your healthcare circle, who have the knowledge of feeding certain information together and providing you this information. What I'm most worried about when it comes to AI and healthcare and physicians is one thing that was mentioned by Ian. I'm not a surgeon, I'm a pediatrician, but I think it's the question of skill. So if you have a robotic or robot that can do a surgery better than you can, why should you even learn how to do it without the robot? And that's a problem because no matter how good any kind of robot is, there's always going to be a small chance that something is going to go wrong. And you may not have a robot who can fix that, but you will need the surgeon who's then going to go in there and try to fix whatever went wrong. So if you don't have the skill set to begin with to do this, that's a problem. So I'm worrying about this a little bit, and I tease my friend Chris Calderon, who's the chief of surgery at Sick Kids, who's very excited about robotic surgeries. I make sure that everybody still knows how to suture something together. The other area I'm really worried about is our medical students. So most of you have heard about IBM Watson. Most of you know about Watson. So Watson can go to medical school in a few hours, as opposed to 4 to 6 years of a human. So if I, as a human, know that I can just put a couple of informations to a computer and get an answer out rather than studying something for 2 or 3 hours or maybe 2 or 3 years, what am I going to do? I'm just going to put it in the computer. So obviously it's not going to eliminate medical school training, but I'm actually really, if you ask me what I'm really worried about all this, is are we going to have physicians that are losing a little bit the creativity of thinking? Because I look at AI as not a competitor and not as something threatening, in fact, not at all. And I'm going to give you a few examples. But I look at AI as my new stethoscope or as another stethoscope I'll be using. It's going to help me make better decisions. But it helps me better decisions because I continue to learn on my own, and I went through teaching and learning for many years. I have been learning about medicine and science for now 23 years, and I continue to learn, and I will continue to learn until I retire or die. But there's a bit of a notion that if you go to medical school and certain computers can just spit out an answer like this, how's that going to affect your learning? Your learning, not the machine learning. So that's a little bit worrisome. So you heard about medical diagnostics as one area. I want to give you a couple of other already existing examples, and then I'll tell you what I think the future is going to be and where we need your help to regulate this and protect it and enable it in a way that we can actually get there within the next 5 to 10 years. So you heard about robotic surgery, you heard about improved medical diagnostics. It's the poor radiologists who always get the short end of the stick here, but I think it's many other diagnostic areas where AI is really going to help you make a decision. It's still going to be you who has to talk to the family or to the patient in explaining this, because that is not something any computer will ever be able to do, no matter how much anybody in this room is trying to convince me. Empathy, compassion, that's not something AI can do. At least I'm going to say this now. In addition to that, drug discovery is already using artificial intelligence networks to design much better drugs. So I think the drugs you're going to see come out in the next 1 to 5 years are going to be much more carefully developed and much more faster developed with much more precision than ever before, because you can now put all sorts of networks, signaling networks together in a very quick fashion and not doing hours or years of experiments. The other area, which is sometimes a little bit ignored, I think, is by establishing networks of machine learning, you're going to be able to identify patients for clinical trials in a much more intelligent way. So right now, when you run a clinical trial, and you're not running a clinical trial for the diseases I care about, because I'm a rare disease person, so I'm talking about big clinical trials of hundreds and thousands of people. You establish an inclusion criteria, exclusion criteria, and as many patients you can enroll, the better it is, and the companies are happy, and you run a trial, and then you get a result, and then you get a p-value out of this, and if 70 or 80% of patients do what you want them to do, then there you have a paradigm shift. Nobody ever takes care of the 20% or 10% or maybe even 5% who don't follow that math. Now, these are not only the gems of biology because they tell you something, you just need to ask what they are trying to tell you, but they can also, with combination of data, probably be picked out ahead of time. So you can pick your patients for clinical trials by utilizing a lot of information you have on all of these patients in a much more beneficial way. Clinical trials are going to be much cheaper, much more informative, and I think are actually going to reduce cost over time. The biggest cost of drug development after you invest into science is running clinical trials. They are extremely expensive. But now let me talk to you about the way how I see AI develop. So as a pediatrician, are there any physicians in this room? Okay, good. So I can feel safe about what I'm going to say. So as a pediatrician, first of all, I like the letter P, as you will see in a minute. If we do our job right and focus on the next three topics I'll talk to you, you won't need an internal medicine doctor anymore. Because the more healthy you keep your children, the more healthy you're going to be as an adult. That has been established. I'm not making this up. There are tons of studies showing this. We're just not very good at keeping our kids really healthy. So the three areas where artificial intelligence is going to enable us to deliver on this promise is prediction, prevention, and precision. And I'll give you an example of what those means. So when we talk about prediction, anybody in this room who had 23andMe testing done other than Ian? Okay, so what did you get back?
What did I get back?
What kind of results did you get back? If you want to share, you don't have to share.
Pretty normal.
It's good to be boring sometimes, right? I know. I did my own genome. It was boring too. So, but what you usually get back from these direct-to-consumer testing is you have an X-fold increased chance of getting this, or an X-fold increased chance of not getting this. How helpful is this in medicine? Absolutely not helpful. So there's obviously a very clear correlation of if you smoke, you have an increased chance of lung cancer. How many people in this room know somebody who has lung cancer who never smoked? Anybody? There you go. My 40-year-old cousin died of lung cancer and never smoked a cigarette in his life. How many people do you know who are 85 and still puffing ahead and don't have lung cancer? Well, so you see this prediction is obviously limited. Artificial intelligence is going to help us to come up with predictions that are actually going to be meaningful. And are going to be meaningful in a way that we can act on them, in a way that we can now go to the next topic, which is prevention. So preventative medicine is another, so that we are throwing around a lot of sexy terms today: artificial intelligence, precision medicine, preventative medicine. So give me an example of preventative medicine, somebody. Figured lawyers wouldn't just go for this, but Exercise, no. Everyone in this room has undergone preventative medicine. What is that? Pardon me? Immunizations. Vaccination, that's preventative medicine. Obviously, there are a lot of other aspects of preventative medicine, but it's so much more than that. Preventative medicine is trying to identify certain risk factors you may have and actually act upon them. So when I tell you healthy children means healthy adults, then I need to figure out what it is to keep a child healthy that is going a little bit beyond just exercise and healthy eating and living in good conditions. There will be more to this, and there is more to this, and artificial intelligence will help us to combine all these data together and actually make sense out of this to come up with preventative prediction tools that will actually have a real impact on outcome of our children. Whether these are children that are healthy or whether these are children who are born with a medical problem, because genetic problems won't go away with AI, that I can promise you. But AI may help us make genetic problems less of a problem. And the last area is precision. So when you hear about precision medicine, a lot of people have different views on this. And even I have to admit, I use this term in a different context. And I will give you the two examples of the context. I'll use them. The one is kind of here already, is an example how machine learning has enabled us to already change dramatically the way how I practice medicine. And that is through the sequencing of the human genome. I tell you a story that illustrates this, probably quite powerful. Before I moved to Toronto 5.5 years ago, I was at Johns Hopkins in Baltimore. And I took care, several years ago, as a young attending, I took care of a child that was diagnosed with a very severe seizure disorder at the age of 3 months. And I threw every test at this little girl that I could think of. It was 18 months of testing, $30-some thousand of costs, and I couldn't find an answer. I didn't know. I tried this panel, I tried that panel, and I didn't know. And shortly before I moved here, Holly died, so the parents gave me permission to use the name. I need to be careful with lawyers in the room. Holly died, and I remember being at the funeral and the mom telling me if I would only know why she died. And I spent a good many years with her, 3 years with her, trying to tell her, don't worry about what it is. I can't do anything about it anyway. Try to lift this burden of question of why. So I came here. Mom called me a few months later and said, I'm pregnant. So I'm very excited. She had her baby in this following spring and then called me 3 months later asking me or telling me that Alexa had seizures. So she had the same disease like her sister. At that point in time, through machine learning, we have come to a point where we could sequence the human genome as a test to find out what might be wrong with Alexa and Holly. I offered it to the mother. We did it, and we actually found a diagnosis in a gene that I never heard about. Interestingly enough, only 3 families in Israel were known to have a mutation in this gene. By now, we know 26 around the world, also through AI-enabled networks that help connect the entire world and data. And I Skyped with the mom, and I have to tell you, the amount of relief I saw in this mother's eyes when I told her just the diagnosis, nothing else. I can't fix it. It's probably one of the most humbling experiences of my professional career so far. Now, you can't measure this. When I'm in very deep, hopefully final conversation with the ministry right now to get genome sequencing approved for everybody in Ontario who needs it, not everybody who wants it, just the ones who need it. And they asked me, well, so what's the diagnostic utility, and how is it changing your management? To be honest, most of the time it doesn't. So how do you measure mental well-being? Just lifting this enormous amount of pressure of why, which I have seen and I continue to see over and over and over now, where I provide parents an answer which they may have been looking for sometimes. The last most powerful case was a mother who I made a diagnosis for her son who's 34. For 34 years he was waiting for a diagnosis. Can you imagine how that conversation went? So we can now, though, begin to think about how to fix those genetic mutations with a technology that requires another conference like this about CRISPR genome editing. Do you know about CRISPR? Everybody? Okay, good. Perfect. Yeah, somebody's very excited about this. Good. Me too. Why am I talking about CRISPR? Don't worry, I'm not going to talk about the genome editing complexities and where you need to help us regulate this actually quite badly. But it's the AI, machine learning, that's going to enable us to design these drugs in the most safe and accurate and precise way and give it to patients in a way that it's going to be very powerful. Last example, I have 1 minute? 1 minute, okay. So last example, though, is what I see coming in the next 5 to 10 years. What AI is going to help us do is the following. Over the last 6 weeks, we saw 978 children in our emergency room with asthma. 978. Out of those, 100 had to come back, close to 100 had to come back again. All these kids get the same treatment. Some respond and some don't. Some have to come back. Sometimes the answer is because they don't have the money, well, although OHIP Plus is helping with this, but they don't have the money to fill the medications. Sometimes the answer is they live in a house full of mold and cockroaches, and that makes your asthma just as bad whether you have medications or not. But most of the time, the answer is going to be somewhere where we don't know yet where the answer is, because it's going to be a combination of your genetic code, of your microbiome, of other ohms, of environmental data. The only way how we can figure this out is through machine learning. Machine learning is going to develop an algorithm that's going to take into account each of the data sets we all carry around with us, or which people who take care of you as a patient measure in all sorts of different areas around University Avenue. And it's going to enable you to manage you as a patient, and not just you as someone who has a disease like many others. That is precision medicine, and this is where artificial intelligence is going to change the way how we're going to make better medicine and perform better medicine. Thank you.
Okay, that was excellent. Now moving to Ryan, are you there?
I sure am. Can you hear me okay?
Yep.
Okay, great. That was a very interesting and inspiring set of talks. Thank you to Ian and to Ronald. It turns out my remarks actually build rather directly on the two of theirs, and so it's a great segue. And just my profound thanks for including me in this effort. One of my great honors in recent years has been the ability to, in whatever small way, to help policymakers in the United States and to some extent abroad try to think through what a wise and inclusive infrastructure would be for artificial intelligence and robotics. And I always jump at such a chance to participate. I wish I could be there with you in person, and I apologize that I could not, but I'm just still very grateful for the opportunity to address you. So I want to start just with a definition. I'm not sure that we've quite said exactly what artificial intelligence is, and I'm not sure that anyone particularly knows or has a monopoly on that. But for me, I think of artificial intelligence as essentially a set of techniques that are aimed at approximating some aspect of human or animal cognition using machines. And so whether we're talking about reinforcement learning or convex optimization, or we're talking about good old-fashioned, whatever it is we're talking about, it's a set of techniques. And so it's not some single monolithic technology, but rather a bunch of approaches, some of which, as Ian alluded to already, have been around for quite some time and are only now yielding the kinds of magical, in quotes, applications that is precipitating conversations like the one we're having today. I had an occasion to sort of lay out a roadmap of what I thought the major policy issues were in the United States. I'm going to talk through a little bit what I think those are, and then give you a set of recommendations that I think are appropriate to this early stage in the technology. And then last, I'm going to talk a little bit about the question of regulation in the sense of actually fashioning new rules and what I think about that prospect of that. So that the set of issues that I've identified, and of course people will have many others, include first issues of justice and equity. And the idea here is complicated. So the first notion is just basically that at a larger general macro level, there is concern in our community that the benefits and costs of artificial intelligence will not fall evenly across society. So, for example, the ability to model consumer behavior using techniques of artificial intelligence is much more likely, I think, to inure to the benefit of corporations selling things than it is to consumers buying them. But we also see that there are contexts where we're experimenting, and I'll return to this, we're experimenting with artificial intelligence on the populations that are the most vulnerable and have the fewest resources to seek redress. And so, there are a couple of different kinds of issues within justice and equity. One is this idea that perhaps artificial intelligence literally will not work as well for some populations versus others. And so, for example, there's anecdotal evidence that people of color, and this is in many ways a very simple example, that anecdotal evidence that people of color, their hands are not always recognized by automated dryers or automated faucets because those faucets have been calibrated to white hands. Similarly, there's evidence that, for example, Taiwanese individuals, people of Taiwanese ancestry, are having an issue apparently where software that is facial recognition software meant to optimize cameras, digital cameras, are not taking pictures or are warning that the subject of the picture is actually has their eyes closed or is squinting because, again, there hasn't been the software upon which the database upon which the software has been trained contains too few Taiwanese faces. So that's just an issue of just artificial intelligence is simply not working as well across all populations. And there's also, though, the issue where artificial intelligence is being used to make decisions that of import, how long maybe someone will stay in jail, whether they are paroled, whether they get housing or extended credit, and so on. And quite a few studies have pointed out that that using algorithms to make such decisions can often reinforce bias and are not as useful as they seem. So, for example, a study of the Chicago's use of predictive policing by RAND, a large independent think tank, research institution, I should say, found that not only was the algorithm not terribly able to predict where crime was going to occur, but it led to more harassment of underrepresented minorities. A second set of, and look, I mean, and this is something that the United States we're thinking about a lot. I know you are in Canada as well, elsewhere in the world. and it's a very difficult set of issues. And so, yeah, but for sake of time, I want to move through them all. The second is that there's a special kind of decision that you might make about a person where their life is on the line. And so I separate that out into another category where it's sort of about the use of force, the use of violence, or even something I don't think any of us would characterize as force or violence, but nevertheless has to do with life, which is end-of-life care, making decisions about allocating resources to people who are in hospice or at the end of their lives. And on the use of force example, and we can talk both about military, international, the use of force by the military in a form of autonomous weapons, something that Ian in particular is a thought leader globally on, but also the domestic use of force and the use of robotics and artificial intelligence by the police. Again, because of the monopoly on violence that the state has, and because of the special considerations, use of force is something that I think is particularly important to think about. And then something that Ian has, in a sense, already referenced, but I think a big, major challenge here around artificial intelligence is going to be around safety and certification. So for all the reasons that Ian and Michael and their colleague write, I agree. I mean, it's going to really radically change medical malpractice with the introduction of these systems that in some cases outperform people. But I'm also interested in the question of how do we know when a system is adequate? So, for example, if you're going to be operated on by a surgeon, she's got to go to medical school and she's got to pass her boards. But under development today in a number of labs are autonomous surgical units, which are amazing at one level because they allow for highly, standardized and presumably one day safer surgery, or even surgery in places where there isn't a surgeon who is available to do this surgery. But at the same time, how do you go about establishing that this surgeon is adequate, given that they're not going to go to medical school and they're not going to pass boards? I mean, what are the tests and standards by which we vet all the robots that are going to be replacing what people do? I mean, another example is driverless cars. How do you establish how much safer than people they need to be? I think is a non-trivial question. Again, for the sake of time, moving on. I mean, a big area that I think that any thoughtful government thinking about AI is going to come up with is the effect on privacy. And as Ian said earlier, the primary benefit of this technology, or its most obvious affordance, is the ability to spot patterns. But because it's so effective at spotting patterns, artificial intelligence is increasingly able to derive the intimate from the available, meaning that, like some kind of super Sherlock Holmes, artificial intelligence is able to spot these patterns and come up with some characteristic from completely publicly available data, or at least from surprising data. So the very same mechanism that would allow, genomic sequencing plus machine learning to identify Hawley's disease is also the same kind of set of techniques that might allow a corporation or a government to derive some pretty personal and intimate characteristics about an individual just based on what they have made public to the world. And that's something I think we're very much grappling in with the United States. From my understanding of Canadian law, which largely derives from Ian and his former student, now a professor at Windsor, Kristen Thomason, you actually have a slightly different regime than we do, but you also grapple with this question of what to do about publicly available information that then allows insights that are quite personal and private. A related issue has to do with because this artificial intelligence is so incredibly data intensive. The reason that we're even talking about it is because access to a large amount of computational power coupled with a lot of data is what's empowering some of these techniques like wonderful voice recognition, for example. It's just really data intensive, and that has sort of obvious consequences for privacy, but has less obvious consequences for the ability of new entrants to get into the field. So at present, artificial intelligence in the United States is dominated by a small handful of companies that have the kind of expertise and the kind of access to computational power and data that they can do this kind of magical applications. And it's very, very hard to compete with the Microsofts and the Googles and the Facebooks and so on of the world. And to get access to their data or their computational power will require some thoughtfulness around privacy. And indeed, these companies may even use privacy, ironically, as a shield to disallow others from getting access to their data. So I think there's also an issue of data parity kind of hidden within privacy. And the last one I'll mention before I move on to the other portions of my talk are the issues of taxation and displacement of labor. I lump them together for the following reason. Imagine that it just winds up that there are a particular set of jobs, maybe even very, very common jobs, that are successfully replaced by automation. Truck drivers, perhaps, if not radiologists. Or just a particular job within a restaurant, like the person who does a particular task at a McDonald's or at a fast food restaurant. Obviously, that is going to displace jobs in the short run. I'm myself relatively agnostic, or I guess was ambivalent about what the long-term net effects of automation and artificial intelligence will be, perhaps to grow the economy and to result in more jobs overall. But in the short run, certainly we're going to be displacing labor, and that's something that a government has to manage. But also, to the extent that you rely upon income tax, that is going to be a big problem because we're going to be moving lots and lots of jobs from an income tax, like, for example, a person who works on making hamburgers at McDonald's, and all of a sudden they no longer will be a source of income tax and therefore a source of revenue for the government. Not only that, but actually because these are machines that can depreciate over time, there may actually be tax relief for automation in some settings. Now, I don't know how much of an issue this is in Canada, but in the United States, there are states that really their revenue projections rely very, very heavily on having an income tax base, and they could find themselves, with a very different fiscal picture over a very short time, just because certain things have been automated, even if those jobs ultimately down the line come back. And so, these are all a set of issues. There are presumably more, but these five issues are the things that I have identified as being recurrent to the discourse around AI policy. To address these and presumably other issues, I've made a set of recommendations. They're not unique to me. I mean, I've definitely cobbled them together from a variety of forums that I've been associated with. Deirdre and I were both involved with the White House series, the Obama White House series on artificial intelligence, and some of these recommendations are seen there. I'm an advisor to something called the AI Now initiative out of NYU. Some of the recommendations are also mirrored there, but there are these. And again, these are like the sort of like what should we be doing right now, given the transformative potential of AI. So the first thing that I identify is that we need to accrue expertise in all levels of government, and that it's very unlikely that we will come up with the wisest law and policy infrastructure for AI in the absence of regulators and lawmakers and judges that have an adequate mental model of the technology and also the access to impartial expertise, hopefully within government itself. I have a paper with the Brookings Institution from a few years ago that lays out a bunch of problems we've already had in the United States where the relevant agency either did not have expertise. And so, for example, surgical robots are an interesting one. Surgical robots in the United States proceeded rather quickly to go through Food and Drug Administration FDA approval, in part because regulators took on its face the claims by industry that these surgical robots were easily analogized to laparoscopic surgery, which is a well understood form of surgery, only to find after they approved them upon fast tracking that lots of problems arose that had to do with the difference between laparoscopic surgery and robotic surgery. And that was a place I thought we moved too fast. But for every example like that, I can give you a counterexample of situations that still are not happening, like drone delivery, something called cognitive radio in the federal communications context, that are not happening because the regulators are too afraid to sign off on some well-vetted idea from industry and academia just because they don't have the expertise in-house. And so I think expertise is critical, and I can talk more about that. Investment, just making sure to invest in basic research, to invest in interdisciplinary research, to not only further the state of AI, but also the state of social impacts research about AI, I think is critical. Procurement, thoughtful procurement, right? So one of the issues we're having in the United States is that people are buying AI-enabled systems for use in places like courts without really understanding what they're buying and not understanding the consequences of it, without asking tough questions, without making tough requirements. So, for example, you buy something without anticipating that perhaps a defendant might challenge its results in court, only to find that the provider of the AI is hiding behind trade secret law and won't tell you how it works. And meanwhile, this defendant has been sentenced to a longer sentence on the basis of recommendation of this software. That shouldn't be happening because the folks who buy it, the governments that buy it, should be asking really hard questions and attaching conditions. This is related, of course, to the expertise question. But procurement's a very powerful thing. It can move markets. If people believe that cities like Ontario, like cities like Toronto, for example, are not going to buy their product unless they make sure that it respects the values of residents, that has the opportunity to move the market in a positive direction. The last recommendation, sort of general recommendation, has to do with removing barriers to research. I have colleagues at the University of Washington that are working on tricking driverless cars. So, for example, showing that you can subtly alter a stop sign so that it looks like a yield sign to a driverless car. And, we're in conversation about whether or not that's lawful research in the sense that is it the kind of thing that would open them up to some kind of at least cause of action by a company that's angry about the revelations. And this is happening sort of across the board where different journalists and researchers and everyone else is trying to kick the tires on artificial intelligence systems that have already been deployed to see whether they're safe, whether they're biased, and so on. And some of them are nervous in the United States that they're going to run afoul of some kind of lawsuit that saying, hey, you can't reverse engineer our system or you're breaking into our system somehow, and so on. And so I think it's absolutely critical to make sure that researchers both have the freedom to evaluate systems that have been deployed or will be deployed and have that perception of that freedom, that they understand that their research is welcome and in the public interest and not going to be subject to the threat of litigation. So that just brings me now to the final point, which is often something that I get if I don't mention it up front, which is, should we be regulating? You sort of, in the United States, there's this the libertarians have been quite successful in establishing that you cannot regulate technology because it's a threat to innovation. But when I speak to Europeans, for example, they ask the question of what should we regulate? And The short answer is that I don't know, but I wanted to mention sort of three paradoxes around artificial intelligence that we're seeing in the United States. This was sort of crowdsourced by myself and by Kate Crawford at AI Now and a bunch of other people sitting around the table. But here's three tensions or paradoxes that sort of highlight what the tensions in U.S. society and presumably Canadian society around this. And some of them have already been alluded to. The first paradox is that somehow to get smarter, we need to know less. In other words, that in order for us to move forward in our variety of professions and techniques and so on, that we're going to be de-skilled, or that we're going to be reliant on black boxes that we don't totally understand. That somehow to advance as a society, we need to devolve. And that's an interesting paradox, and one that I think that regulation might have a role in mediating. A second is something I've alluded to already, which is that sometimes you hear people talk about how artificial intelligence is going to take over the world and it's going to kill everybody and it's going to become super intelligent. And often practitioners of artificial intelligence will push back against that by saying, "Oh, come on, artificial intelligence is too stupid to threaten us. It's in early stages. It's held together by duct tape. We don't even understand it." But then the same researchers will turn around and say, however, we should immediately deploy artificial intelligence in our most sensitive contexts, like hospitals and prisons and schools. I don't mean at all to paint Ronald in that light. I know he's being quite thoughtful about the literally life-changing effects of a properly deployed system. But even his example of asthma is very interesting in that presumably asthma treatment will improve as we personalize and as we become more subtle in our diagnosis. But there was at least one study suggesting that a triage system deployed in a hospital, which was supposed to tell us whether or not certain diseases or certain symptoms that came in the door were dangerous or not, that actually that system misdiagnosed people with asthma as being low concern, precisely because it trained in a data set where everybody who came in with asthma was rapidly given, an inhaler and rapidly treated, precisely because it's so dangerous. And so the system misunderstood asthma as being not a big deal, especially because it's such a big deal that we immediately address it. And so that made a recommendation saying people come in with asthma, you should not worry. Send them back to the waiting room because they'll be fine. They're only fine because we take it so seriously. So there are lots of places where the deployment of artificial intelligence that it truly is early stages and in some ways is little understood can be dangerous. My final point is this. This is the final paradox that I think I see, or the final tension that I think we see in the U.S. is that you simultaneously hear the claim that artificial intelligence will change everything, but nothing should change. In other words, artificial intelligence is going to remake every aspect of society. It's going to change how we do everything. It's going to change the nature of work and the nature of play and everything else. But there shouldn't be any change somehow to law or legal institutions. That strikes me as deeply implausible. Either artificial intelligence is all hype, or we're going to need to change our laws and legal systems to address it. And so I think regulation at some level is inevitable. I think it's premature today to top-down regulate everything, but I think we should be watching for opportunities where there's a gap between what the law assumes and what is actually happening on the ground in practice in light of this new set of affordances. And with that, I'll end hopefully on time here and look forward to your questions, and I thank you again for the opportunity.
Okay, great. Thank you. Okay, we'll go straight to you, Deirdre.
Sure. So I do have slides, and I fear it's going to be slightly awkward, but hopefully you'll bear with me. Like everyone, I am very grateful to have been invited, and like Ryan, I'm very sorry I'm not actually there, and appreciate you accommodating my health and letting me do this from here. So I think this presentation is actually going to build very nicely as well. I'm going to be talking about critical engagement with AI and this goal that I want to suggest, which is designing for contestability. If you could advance to the next slide. Ian already talked about the fact that what we're really doing is we're delegating, making decisions about which functions we want to delegate to technical artifacts. And we're delegating a whole range of functions that impact values, sensing, interpreting, deciding, acting. And you can think about it very much like a baton in a relay race, that the responsibility is being handed off from a human to a machine. And with that function, we are often failing to interrogate both kind of the societal values and I would also say kind of the professional norms that might need to flow with the function. You could go to the next slide. And we're seeing these handoffs being used to assist, right, so decision support systems or to replace human decision-making in a wide range of circumstances that can have super high influences around access to resources or services in the fields of criminal justice, medicine, investments, so it's things like robo-advisors. And while historically expert systems and other technology have raised questions about transparency and the unwitting delegation of institutional or professional judgment to software engineers, requirements engineers, etc., there are unique challenges posed by the use of these predictive systems, which have been discussed this morning. They are not designed by engineers in the traditional sense, right, but rather they're designed in many ways by the data they train on, which creates some unique challenges to ensuring that systems accord with professional expertise and judgment, right? It's more difficult to do that in an ex-ante way because, as Ian described, the systems are learning over time, right? And so their judgment is changing. Some of the algorithms, and not all, but some, make it difficult to understand the rules that they have learned from the data. So unlike an expert system where domain professionals can review and interrogate rules, these systems can provide insight into the inputs and outputs, but we often lack the ability to easily interrogate the actual decision-making processes, how those inputs are weighted or balanced against one another. And then finally, the systems are probabilistic and dynamic, right? So they don't have one right answer. They need not make the same decision about two people the same way, nor the same decision about the same person at 2 points in time. And this sort of plasticity challenges even the oversight that is provided by examinations of inputs and outputs. And it's a real challenge when we are thinking about concepts such as bias and fairness when we have these dynamic systems. So these predictive algorithms are embedding many subjective judgments about the data to train on, how to clean it, how to weight different features, what algorithms to choose. All algorithms are not created equal. How to tune and on what part of the system designers should tune. What should be included and excluded in the system, etc. And sorry if you can move slides. And so for these reasons, the handoff to these algorithmically driven systems have been met with calls for greater transparency, interpretability, increasingly explainability. And there are multiple and overlapping and to some extent distinct concerns that animate these demands to quote-unquote open up the black box or disclose the code. Some advocate for transparency in response to harms propagated by algorithms trained on poorly chosen, unrepresentative, or historically biased data, and we've seen that, for example, in the risk recidivism area. Others advocate for transparency due to the biases that may intentionally or unintentionally be built into the algorithmic design choices themselves, right? So there's this concern that that the people who are making choices about the algorithms are not as appreciative of the sensitivity to the data that they're working with, right? That the problem is not as evident as they might think it is. Others are concerned with the harm caused by the secretive displacement of professional or organizational logics of a specific domain and institutional expertise by the logic of software developers and technologists, right? That this really is about kind of which professional guidance is going to influence. And I think others are concerned with the ease with which algorithms and code more generally can cloak actual malfeasance, making it difficult for regulators to evaluate, enforcers to oversee, and the general public to trust products and services. So I'm going to talk a little bit about how some of these key terms of transparency, interpretability, explainability are being used in some different disciplines and what they seem to mean. And then I'm going to look at how two different professions have approached algorithmic decision support systems with respect to these issues and ask, but not answer fully, why they're approaching them differently and what we might take away from this. And then finally explain why the emphasis on explainability or interpretability is insufficient to address both concerns around democratic norms as well as concerns around domain-specific deficits with respect to algorithmic decision support systems, and close with some recommendations. So if you can move to the next slide. So transparency, one of the things that's really useful when you're having these interdisciplinary conversations to have a sense of how different communities use terms, because you'll often be using the same word and assuming that its meaning covers different domains, and it doesn't. And when we look at terms like transparency in the statistical and social sciences, they're generally thinking about opening up their design and analysis and processes for others to use. And it's very much aligned with the whole movement around reproducible research. And it is a pretty rich understanding of transparency, and one that you can imagine being quite useful in thinking about the need, our need to understand how systems to which we're delegating important tasks perform. In computer science and law, transparency tends to be construed much more narrowly. It's around openness, either of a model or a system internals. And it tends to be much less focused on the development of the model or the cleaning of the data, things that for statistics and social sciences are viewed as kind of an integral part of understanding a system. If you move to the next slide. Interpretable or intelligible. What does that mean? Well, people are tending to focus on, does the model or system make sense to humans? But then there's an alternative, which is, do the outputs of a model or system make sense to humans, right? And if you were aiming for one or the other of those, you might have a very different focus. So generally, responses are to constrain the class of potential models or systems to those that do either both of the above. And I'll talk a little bit about some of those systems. Ryan was alluding to one earlier. And typically, the demands for understanding don't apply to the techniques used to train the models, the data collection, or the cleaning, right? So the focus is really on, is the model itself interpretable, right? So kind of a dislike of a neural net and a preference for things that look more like decision trees, because they're things that humans can, with some effort, work through. But those tend to kind of glide over the fact that many of the concerns that we've seen arising in the marketplace or in practice are actually at the intersection of the models and the data. If you can move to the next slide, please. So explainable AI and machine learning in the social sciences has been thought of as both a process and a product. So a process, thinking about it as the transmission of an answer, right, so that you don't just get a result, but you actually get an answer that has some meaning, meaning the product also includes an explanation. Sometimes it's thought of as causal, so, it's not just an explanation, but really answering the why an event occurred, right? And so it involves some selectivity, because human explanations tend to highlight a few key causes, right, rather than be exhaustive. We don't ramble on. We try to give people, whether you look under disclosures that are required in the context of credit or other areas where there's requirements for people to be given information about why they were treated in a particular way, that we tend to highlight the few key causes, right, that offer the best solution. And as I mentioned earlier, if key causes keep changing, that can be quite a complicated way to think about explainability. Sometimes we think about explainability as contrastive. So what we really want to do is help people understand why X happened instead of Y. And in those instances, we tend to get a really selective explanation, right? It's because you didn't, or because you don't have, or because, et cetera. And those are super narrow. And again, only if that input is the one that matters the next time around would that be a useful explanation for somebody who is trying to understand the performance of a model. In the social sciences, explanations, I think at a very high level, are thought of as a means to transfer knowledge. And I think that's probably the most useful definition for thinking about the relationship between humans and machine learning and AI systems as a kind of regulatory objective. You can move to the next slide. In machine learning and AI, computer science, explainability is a very big gun, right? They tend to be thinking about entire descriptions of what the model or the system does, or looking for systems that produce rules that can be identified and fully interrogated. Okay. So next slide. So I want to now look at two particular domains, healthcare decision support systems and the judiciary risk recidivism systems, and look at how their professional dispositions to algorithms may be altering the way in which they're thinking about the interface and the need for interpretability or explanations of particular sorts. Next slide. So when I started this work, I was trying to understand how the healthcare domain generally approached the adoption of technical tools, and I found this very nice work, which these quotes are pulled, talking about a kind of attitude of progressive caution, right? And that basically pointing out that that as a field, they were very attentive to ensuring that tools that were being adopted were consistent, not just with their practices, but consistent. They were kind of optimally ethically, right? And so not a kind of enthusiasm for all technology, not an early adoption sort of system, but one where there was some deep reflection on the way in which technological change can open up new risks, and that there was a real ethical imperative to avoid errors and to maximize the positive outcome of adopting a new technology. And so this kind of attitude of progressive caution. Next slide. You can see this evident in healthcare in the regulatory setting where, we in the U.S. we regulate medical devices, and there's been quite a long effort to try to figure out the extent to which things that are called decision support systems fall in or outside of the general rules about medical devices, which undergo a particular kind of regulatory review before they can be used in practice. And towards the end of the year, 2016, the FDA in the U.S., the Food and Drug Administration, regulatory agency that is responsible for this area, at the behest of a new law that Congress enacted, drafted some guidance that says that clinical decision support systems that enable healthcare professionals to independently review the basis for recommendations coming out of decision support software, so that they are not intended for the healthcare professional to rely primarily on any of such recommendations to make a clinical diagnosis or treatment decision regarding an individual patient, would be excluded from the FDA device regulations. So this is very interesting because it's saying here's the path towards having your AI-based system, your machine learning-based system, get to market quicker and avoid some of the more cumbersome regulatory processes. And it says you have to enable the healthcare professional to independently review. So if you go to the next slide, this sets up that question of what does it mean to enable independent review? And so what I wanted to do is look at both how the FDA provided guidance on what that meant, and then in a little bit more detail, look at how industry that's developing these tools, and in particular, I'm pulling from, there's a coalition of medical decision support software companies that have been pulling together some self-regulatory voluntary guidelines in this area. So it was super interesting to me in looking at this, right, that in the transparency, what do they think providers who are going to be relying on these systems need to have access to? It was pretty broad, right, and super important. It was not just about how the system functioned, but also about the limits of the system. And, you say, well, what does that mean? Well, when we think about some of the horrible financial meltdowns we had here in the U.S. And globally, some of those were not about the functions of the model. They were about the assumptions and limits of the model, right? That if you assume certain things to always hold true, and it turns out those assumptions are bad, it doesn't matter how good the function of your model is. And so here I think it's very interesting that they're looking at both the function and the limits, and limits implicitly incorporates, I think, kind of assumptions. So you can think about when you're looking at a system, one of the more important things to do is to actually understand what were the design objectives. And when we're thinking about function and limits, it means you're not just looking at what the system looks like, but you're looking at a more holistic perspective on what the system was intended to do. Indication of the certainty or reliability, right? So some clear indication to people who are relying upon it about probabilities and about accuracy, right? Inputs. They're looking at providing transparency about the patient information, where it's coming from, what sort of data it is, but also about the source of the clinical information and the decisional rules. And for the trade association, they said if the risk of serious injury or death, you need to explain the rules, in addition providing kind of a reasonable explanation of the clinical logic that communicates the clinical thought process, but not necessarily the computer science functionality, right? So if we go back to those earlier definitions, this is not a computer science, you need to open up the code. It's more of a social science. You need to actually be able to ensure that I can understand the way in which you're reaching a conclusion. It's about kind of transference of knowledge to make sure that you're doing what I think is the right course of action. In the FDA's guidance, which is voluntary, there's some even more specific language that I think warrants some reflection. And it says that in order for software to be considered to be offering independent review, the sources supporting the recommendations or underlying the rationale for the recommendation should be identified and easily accessible. And more importantly, the data points whose meaning, the data should be publicly available. It should be coming from clinical practice guidelines and published literature. And they have a particular line where they say a practitioner would be unable to independently evaluate the basis for a recommendation if that recommendation were based on non-public information or information whose meaning could not be expected to be independently understood by the intended healthcare professional user. Setting up, I think, a suggestion that proprietary algorithms would be quite complicated in this area. In addition, it requires competent human intervention. And competent human intervention, in part, means that you have to have the right professionals with the right level of training and expertise to be using the decision support system. when you look at the guidance, one of the things that both the FDA and the providers of the technology, the vendors, are concerned about is that clinical decision support systems will end up displacing particular professionals by suggesting that other people, perhaps with less skill and training, aided by a system, can now engage in a particular kind of medical diagnosis. And there's a real concern that that not happen, that these are supposed to be supportive, not displacement. And finally, there's an emphasis on the sufficient time to reflect provision, which I think is very interesting, and saying that this cannot be in the context where doctors are like pressed to make a decision, because in those contexts, we want things that have gone through the regulatory process and function more like tools, not as decision support. You can go to the next slide. In the interest of time, I think I covered most of this, so I'm going to say, go one more slide, please. So in the context of the healthcare decision support system, you can see a bunch of things that are being identified as particularly problematic. So using a decision support system for a purpose that it was not built and on data that it was not trained, right? So using without respect for the disparities in the training data and the data that it's actually going to be ingesting. Use of a system without training. So people who are using it can't be ignorant of a system's designs or its capacity, meaning its strengths and limitations. Expanding participants in an activity who don't have the right professional competencies. And then finally, using without knowledge of how the assumptions, limits, or model align with professional commitments. I think those are all things that you can take away from the guidance, both self-regulatory and regulatory in this area. On the next slide, I just really wanted to think about how that compares to what we've seen with respect to the risk recidivism software environment. I first wanted to point out a paper by Alan Goodman and colleagues where they looked at how states, or counties actually, and cities were adopting various forms of machine learning-based tools. And they found very little engagement with software development, right? It was not a co-development process. These things are basically being procured in a very off-the-shelf sort of way, which meant there was a very little understanding of the requirements, the strengths, the limitations, the assumptions built into those systems, and in particular, the extent to which they were trained on data that might be representative of populations on which they were going to be used. Second, I wanted to point to the Loomis case, which we might talk about later, but it was a case that went all the way up to our U.S. Supreme Court, although cert was denied, that involved the use of risk recidivism software in the context of sentencing. And we could see there that's a use for a different purpose. Two, it was used without respect for disparities in the data it was trained on and the data it was used on, right? Three, it seems to be being used largely without adequate training, that the system went all the way up to the U.S. Supreme Court, and in the U.S. government's brief, they basically argue that the issue of gender and whether or not there's a discrimination challenge to the use of the system as it was used isn't right, because nowhere from the proceeding below can they figure out whether what gender was used as an independent variable in the system or to norm the system. And I would suggest that professionals in the practice of justice that are relying on a system that is supposed to be acting in a way that is consistent with due process and equal protection should know the answer to that question, right? Yet it had gotten all the way here. Okay, if you can go to the next slide. So I just wanted to close with some particular recommendations, and one is pointing to kind of the need to preserve political visibility over values. And I have some different authors who have been writing about this issue. It's clear, both Ryan and Ian talked about procurement, and we see many of these systems being adopted through processes that don't look like policy-making processes, but rather look like procurement processes. And those procurement processes don't tend to have the same kind of open interrogation of the values implications that are built into systems. And as we move functions into systems, one of the things that we often fear losing is political visibility into the value choices that they're making. And so I think that there's a real need to rethink the way in which these systems are construed, because these systems, particularly ones that are learning over time, they are now sites of values on an ongoing basis. And so we need to rethink where they're situated. If you can move to the last slide. I just want to close by saying, and I think we need to move away from asking for transparency or explainability and actually push for contestability at runtime. And contestability is the idea that if I'm a doctor and I'm being asked to rely on a system, that the information should be presented to me in a way that actually demands my engagement, not my obeyance, right? And we can look at in other areas of law, and given that this is a IP forum as well, you can think about the Aetna casualty case, right, where there was a concern about the extent to which pilots were blindly relying on the presentation of a map, and if they did that, what that would mean for their kind of exercise of their professional responsibility. And, you know, the goal here when we're thinking about handing off various components of and complicated activity, for example, in the medical domain, is to try to make sure that we're leveraging the best of the human and the best of the machine. And I would suggest that the best way to do that is to make sure that they're in dialogue and that humans have the capacity to interrogate and understand the machines, not just to take their answers at face value. And I'll close with my last slide, but just so you can see it and say thank you for your attention.
All right, thank you. So, in the interest of time, I think we'll just give a big round of applause to our outstanding speakers and save our questions for the other panels, and we'll take a health break for the next 10 minutes, so we'll see you back here at about 10:50. So big thank you to our outstanding panelists. I know I was very touched, and I look forward to the discussion in the next, I guess, the next few hours together. So thank you so much.